Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be building a custom ISO for Alpine Linux. It should be a lot of fun, so let's go ahead and get right into it. Alright, so what we have a standard Raspberry Pi. We're going to be using this as our development environment to actually do this. It just happens to be a 8GB Pi, but we are going to be using an external USB thumb drive that we're going to be mounting in order to make it have enough space to actually do the work that we're trying to do. So we're going to be creating a custom ISO, and what that is like pretty much when you download it off of the Alpine Linux website, you're downloading an ISO or you're downloading an image file, and that's going to pretty much have the default, vanilla type of configuration. But what if you wanted to customize that? So I found this webpage on their wiki, which is how to make a custom ISO image using mkimage. And it actually is not restricted just to the Raspberry Pi. The instructions pretty much work for all distributions. So we're going to be just trying it out. I haven't tried it before. We're going to see how it goes, and we're doing it from the ground up. So we're going to see how that goes as well. So first thing we need to do is we need to build our development environment. So right here I have pretty much an old image that I think will be fine to start with. I'm just going to delete the APK OVL file, and I think that'll be just fine. So let me eject this and let's get that booted up. And I'll just go ahead, pop this in the Pi, and let me plug it in really quick. And we do have another Pi that we're actually going to be testing with. So that way we're not kind of competing for our development environment in addition to our actual test bed. Alright, so that's going ahead and booting up. Let's actually switch over to it. Give it a moment. I hear it running, but I do not see it doing things. Oh, green light's on. Let's see what we got. So hopefully everybody's having a fun and exciting pre-summer day. It wants to do things. So what is it doing now? Otherwise, we're just going to blow it out and just pretty much make a new image. Let's see. All right, let's just blow it out and make a new one. So the thing with the Pi 5 is that it has to be using the ARM64 version of it in order to actually run, but it should still show our boot screen. So switching back over to here, see if my mouse comes back. Okay, so we're going to clean this. So pretty much since we're on Windows, we're going to do CMD. We're going to go and do disk part. Right, this is going to open up the command line partitioner for Windows. We're going to list our disks. And we see disk 1 is the USB thumb drive, or the SD card. So we're going to do select disk 1. And then we're just going to type clean. And what this is going to do is it's going to blow away all of the partition tables, everything else like that. It's just going to be a raw disk. So now we can exit this, we can exit that, and we can go in and repartition this. So I'll open up File Explorer again, right click, we're going to go to More Options, and then we're going to go to Manage, Storage, Disk Management, and here we see it's just pretty much a blank disk. There's not even a file table of any kind on there. So we're just gonna give it a file system, specifically FAT32, get that all formatted, and let's just copy on our OS. Now the big thing is we want AArch64, which we should have in here. Let's see what we got. So we have this one right here, and we'll just extract that to the actual drive. And this is exciting stuff going on. We're watching it copy. And the intent with this is to just come up with, will it work? You know, can we actually make it do some custom installed packages, things like that by default? And it may be something we use down the line, because especially for embedded systems and actually getting everything deployed, if you're doing this in volume, is really, it makes it a lot easier. So that way you're not having to do that customization on each and every machine. All right, so now that we have this actually built, let's go ahead and eject this. All right. We'll switch back over to the development Pi, and let me get this plugged in. Will it boot? I don't know if I saw a cursor, if that was the thing. Let me check, make sure this is actually. It is. I have another Pi here, so let's try that one. Oh, maybe it was the USB thumb. The USB thumb drive was plugged into it, and I'm actually not sure what was on there. Let's just give this one more shot. Let's see. This is all the way on the other side of my desk. So this is without sans SanDisk. And let's see if it comes up with anything. Otherwise, we have other Raspberry Pis that we could potentially try. It doesn't actually matter which particular type of Raspberry Pi or anything else like this. It also could just be an x86 computer, a Docker container, or anything else like that. It doesn't really care what it is. But apparently it doesn't want to output video. All right. We will give it one more try. So this one is the offending unit right here. So we're not going to deal with that at the moment. I'll figure out what's wrong with that later. So instead we have this one, which is only 4 gigabytes, but should still be fine because we're going to be using that external storage. Oh, I wish I made these cables longer. I literally use this for, like, leading up to this. Let's just check. All right, let's use this Pi. Nobody's got time for this. Let's see. So this one works. I don't know why the Pi 5 didn't want to come up. All right. So now that we're in here, I'm going to plug in the USB thumb drive into the back of it just to make sure that we can mount it for storage. Alright, and that's in. Okay, and this is an 8 gigabyte Pi 4. So let's log in, let's initialize this. So root, and then we'll do setup Alpine. US. So for this one, I'm just going to call it dev, that way we know what it is. Oh, lowercase only, dev. DHCP. Done, no. So that's just network configuration. I have done some other videos on exactly what I'm doing here, so I'm just going to speed through it. We're going to set a very secure password. And we are going to be doing this over SSH, just in order to kind of keep everything easy, so we can do copy-paste. So we'll choose Crony for our time server, but for SSH, we are going to allow root login. So we'll set our APK mirrors, so we're going to choose C for enabling the community repositories, and then we're just going to choose option 1 as the default. We're not going to set up a user, otherwise it wouldn't present us that option. We're going to use OpenSSH for the server, and we're going to type yes for allow root login. No SSH key in this particular case. It's asking if we want to do a disk install. We don't want to do that. So we're going to keep configs on mmcblk0p1. Same with our cache. We'll do APK update. Perfect. All right, so now we can actually mount our drive. So if we do ls/dev, and actually let me do /SD star just to show only the SDA devices. And because our SD card is showing up as mmcblk0p1 for our actual boot partition, the only SDA is going to be our USB drive in this particular case. If we were booting off of a regular hard drive or booting off of some other mechanism on like a regular PC, it may show up differently, but on the Raspberry Pi, this is very consistent. So SDA is what our current partition is, but the problem is it's formatted as FAT32. We want to change that format and actually do ext4. There we go. It got it out. ext4 for the actual file system itself. So we need to actually install the formatter for that. So we're going to do apk search, and we're just going to do makefs. And it's going to search for the executables that are available for it. In this particular case, this right here, which is E2FS progs, contains the ext4 formatter. So we're going to do apk add E2FS progs. It'll install that really quick, and now we'll have makefs, and if we actually just tab, we see we have ext2, ext3, ext4, and vfat. So we want to use ext4 just because it's journaled. It's a little bit easier to go with. Doesn't really matter, but it does. It's not going to give us a file size limit or anything else like that. So ext4, and then we put the name of the partition that we actually want to use. In this particular case, we don't have to go in and partition it just because it's an out-of-the-box USB thumb drive, so it has one partition on it. But if we did want to set it up differently than what it is, we could go in and repartition it prior to this point. So we're going to do dev sda1, which is the specific partition name. Are we sure we want to proceed because it has a vfat file system? Yes. So now it's going to create all of the blocks and actually apply the format. This is very quick, and it's done. So now that we have that, we can actually add it to our fstab file in order to be able to make it start and mount on boot. But we got to give it a place in order to mount in the first place. So a good place to put it is in the media directory. So if we do /media and we spell that right, we see currently in the media directory we have USB, MMC, BLK0P1, floppy, and CD-ROM. So we can actually mount it to USB. So let's do, and actually it may actually mount automatically. Let's see. And I'll show you why that's the case. Okay, it does not boot. It does not. So let's actually edit our fstab file, and I'll show you the code that I'm referencing. So we're going to do vi, because we're going to use Vim for our particular editor for today, /etc/fstab. And here we see our USB disk. Sometimes, if it detects it on boot, it will be able to mount it there automatically. In this particular case, it doesn't, and that's fine. We're just going to get rid of this line because we are going to use that for something else. So I'm just going to tap D twice without being in insert mode to actually delete that line. And then I tap the I key in order to go through and enter insert mode. So let's add our actual entry for that drive right now. So we'll do /dev /sda1. We'll tab over, we'll do /media /USB. We will tab again, and we'll do ext4. Then we're going to do default 0 space 0. Okay, and we write that out. So let's remount all of our drives again. So mount -a, which will read from the fstab file and let us know if it's actually valid. And invalid argument, it's defaults, not default. Perfect. So now if we df-h, we do see it right there at the bottom of the screen. So it's mounted. We got plenty of space available. 56 gigs is going to be more than enough for anything that we're going to be doing here. So let's save this out. Okay. So now that we've kind of gotten the baseline here, let's actually hop back to our computer and then connect to it through PuTTY. So before we do that, I want to find out what the IP address of this is, and it is 105, so 35.105. All right, we're going to accept it. This will also make the text a little bit bigger, which I think will be nice. And we will get logged in. Perfect. So that's going to be our development environment. So let's put this on the left side. Let's put this on the right. Yeah, I think it wraps all right. So we're just going to be going through this line by line, and to just kind of give an overview of what it's actually doing. Oh, excuse me. Of what it's actually doing is we're going to install all of our dependencies and prepare our user environment by creating a user, DOS, which is similar to sudo, and giving it some permissions, entering it, generating some keys so that way we can authenticate our build for things like package indexes, things like that. And then going down, we're going to clone the actual aports repository, which has the scripts that we need in order to build this. The update using sudo permissions, equivalent using do as. That's, if I call it do as and do as, all the same thing. And then we go in and we actually change configurations, things like that. So we'll get into that in a little bit. So let's start right here. So we are currently logged in, so we can go ahead and install our dependencies. SysLinux is not available. We may need Edge. So let's see. I'm going to try installing the rest of it first, and then we'll see where we get to. And I did put a link in the description to this wiki if you want to take a look at it for yourself or follow along. Might be a bit easier than looking at it on a small screen, or if you're watching on your phone. All right, and let's try doing SysLinux again. And it says it's included as part of Grub, which was installed. So we may not actually need it. We don't know when this was actually written, this particular thing. Oh, we could find out, but it doesn't really matter. So it may have been a separate package that was then integrated as part of Grub. So let's just keep moving on, and we'll come back to it if we need to. And then if we want to boot EFI, we got to actually do this as well. And in this case we do, because most modern operating systems would require, or most modern machines would require EFI. Otherwise you got to put them in legacy mode, which gets annoying. All right, we're going to add a user. It's asking us to set a password. I'm just going to set a very secure password once again. Okay, and then we're going to give it user-like or root-like permissions. So we just created a new file, so I'm going to go hit insert mode. I'm going to paste this in, and it's just going to allow it to pretty much do everything. But it will prevent a flag from coming up saying you're running this as root. And now we're going to change over to that user. So before we do that, let's do lbu commit-d, just so that way we're saving our progress. Let's copy this, paste it over here. All right. And then I'm going to do who am I? And we're currently build. So excellent. We're in our home directory. But now we need to generate some keys. And this is going to automatically install our keys for us as we actually need it inside of the etc apk keys folder. So it's going to be generating it. Where do we want to put it? Let's choose our defaults. And the key thing is, once we do create these, we will actually need to go ahead and make sure it's added to LBU, otherwise it'll get blown away on the next reboot. So, and that would actually cause problems with signing things in the future. So, it says please remember to save it to a safe place. So let's just do that right now. So we'll do LBU add /etc, or excuse me, /home /build, and then we'll do star. So everything inside of the build directory should be included. And we may need to do doas. There we go. So now everything is there. If we do LBU list, we do see that it's present right there at the bottom. So we could do as LBU commit-d. And let's save that out. Perfect. Let's make sure it actually saved the keys as well. So we'll do this ls command and just verify that it's here, right there at the bottom. Perfect. So the next thing that we want to do is we want to actually clone our the Git for Alpine Linux A ports. So before we do that, let's move over to a working directory. So we're going to cd into /media /USB. Right, and it's just an empty drive at this point. So right now, 56 gigs available. So Git, which was installed as part of the Alpine SDK, is what's actually going to download this. And if you haven't used Git before, pretty much it's a way to be able to track changes and things like that through a life cycle of a particular program development. So we're going to do it. Let's see, A ports permission denied. Oh, it doesn't have permission. So we're going to do as chmod 777 /media /USB, and we'll actually, just for good measure, make it recursive. And let's try it again. So now it's cloning everything into that particular directory. And I don't actually know how big it is. And something I was hoping to use the Raspberry Pi 5 for was to actually make sure that it was going to, and let me make this full screen, was to make sure that it was actually going to be quick in terms of any compilation or anything else like that that it has to do as part of building this. It is building it from source, in effect. So, you know, just something to keep in mind is it's not necessarily going to be just a copy and paste and edit kind of scenario. So we've already downloaded all of the files. Let's go back over here and let's take a look. So we're going to do APK update. Which we did earlier, but nothing wrong with doing it again. And if it is alright, I'm just gonna pop back and forth like this. And then we need a temp directory large enough. And it looks like it does just need to be here, and then we define it. So what this is saying is it wants to create it using the actual RAM. So technically we can do that as well. So let's go ahead and follow what this says. I mean, technically our drive is big enough to where our temps folder, if we do df-h again, we see our temp. I mean, honestly, our whole OS is on a temp, but we have about 4 gigs to play with. So we could just leave it alone, and that's more than the 1 gigabyte that they recommend for the build. So let's actually just leave that. But for the purposes of this, we have our 8 ports here. Let's see how it goes. Let's just try it. Let's see. So, the make image scripts are shipped with pre-configured profiles. So the format is makeimage.profilename.sh. All right, and we can take a look at that as well. So if we open this up, just normally in a browser, we can look at scripts here, and we can see the makeimage.arm, .base, miniroot, netboot, standard, and zen. So you can pretty much create any flavor that you want, but still be able to apply those customizations to be able to make it work the way you want. So back over here, if we wanted, so the example that it gives is actually installing ZFS as a default. So coming in, they want to call it NAS as the profile name. Things like that. So we could actually do this. I don't think that's a, yeah, why not? So we're just going to do the default, and let's see what we come up with. So we're going to still go into our working directory, which is 8 ports. And then we saw that it was inside of scripts. So we're going to cd into scripts. And we see all of the available scripts there. But let's go ahead and paste what we just copied. And it has the thing. So we should actually... Let's do this. So I'm going to cd back to the home directory, right? Because we have nothing in our home directory. I'm going to link with a symbolic link to the 8 ports directory. So we'll do /media or / target destination. Yeah. So /media /USB /8 ports. And we're going to put our link directory, which is going to be tilde to symbolize the home directory /8 ports. So now if we ls our current directory, we do see, and we can do ls-la, and we see 8 ports is currently pointing there. So if we try the same exact thing once again, where we just paste this, now it just works. Right? Because it's the same thing as if it was residing within that directory, even though it's a completely separate drive. So, going on from there, we need to set it to executable, so let's go ahead and do that. Then we need to make the packages available on boot. So a package may be made available of the live system by defining the generation of an APK OBL, which contains a corresponding etc APK world file. So the gen APK OBL, and if we actually go back in here and look, we do see these here. So we see the DHCP, Zen, all of that. So we can actually CP this particular one and then modify it. And we're going to do the one for DHCP. We just looked at it. Where is it? Well, luckily we can actually just go back over here. Let's just see what it wants to be called. Oh, so they have a typo. So they put a port instead of a ports. So that's where that was going wrong. So let's go ahead and just fix that right here. They did the same thing twice. The other one also says a port. Is it actually a port and I misnamed it? No, it's a ports. I mean, the other command worked, so I think somebody who typed this just made a typo. Now it works as expected. Spelling counts. So, going back over here, we're going to edit the file and add the following. So, specifically, we're going to edit this file right here. So yeah, at the existing location, it doesn't want us to copy and paste this all in. So scrolling down here where it says Alpine base, because that's pretty much all Linux, the Alpine Linux is Alpine base. So we can add additional packages here as well. So for example, something that I think is really nice to have, and I'll show you this really quick. So if we do lsblk, it's not found, but let's say we had NVMe drives natively on our system. We would want to add that to actually be able to list our particular drives to be able to see what everything was done. So apk, let's do search lsblk to list block devices. Right? And it's just lsblk in this particular case. But, so let's try it. apk add lsblk. Okay, so it just installed it, so we do lsblk. And it will show us exactly what drives are, what block devices are currently attached to our system. So, you know, I think that's a good utility to be able to have by default. So let's go ahead and add that. So we'll go down here and we'll put lsblk. In this particular case, we don't actually have to add it by default, but something else that we could potentially add is like light TBD for HTTP server. So we could try that out. Let's see what we got. And pretty much here, and this is not typically what you would normally want to do. Like you would want to put boot services, things like that. So you have more, it's a more agnostic thing. But we're just putting in some things as an example to show that it can do it. We're going to do rc add, and we're going to put light TBD. And I think we may be able to do that. Let's see. Cool. So let's try this. So going back to our instructions, we've added these things. So in our profile, we need to put that this is the APK OVL. Right, and of course that's referring to this profile here. So we can actually use this command in order to be able to edit it. We'll do vi and then we need to see what we need to edit. So we need to add this. Right there to the end. So that's perfect. And here we see the APKs that it would actually put in, which means our overlay is not necessarily perfect, but you know what, we're gonna see what it does. So something else we could add is also like FFmpeg isn't something that doesn't come by default. So we could try that. Let's add that to that. All right, just so it's a little bit custom, so we could tell the difference between what was there and what should be there. So now we need to create the ISO, which we would use mkimage.sh. So key things are, we need to define the arch, because obviously the default is going to be x86-64, which may not actually be what we want. You know, we may want it to be able to boot onto something else. Actually, we could do that just for fun. So I have this little x86 computer. So we could try cross-compiling. But technically we could build it for both. So let's see what we got. And then host keys, so the APK signing keys for creating the images, those are the keys that we generated earlier and backed up in our home directory. Out directory is where we want to put the created image. In this case, we're going to put it on our USB drive. Profiles, repositories, everything else like that. We'll go through it with the example when it says it. So first we want to create an ISO directory in your home directory. So in this particular case, I want to do... So we're gonna make a folder inside of our USB drive, and then we'll do another link back to our home directory. So media, USB, and then we'll call it ISO. And then we'll do ln-s/media USB ISO. And we will link that over to ~/ISO. That way it matches up with what they were defining here. Then we need to create the actual ISO, and in this example we'll use the Edge version for x86-64. So we're going to need to modify this a little bit. So specifically we need to modify this to say ARM, but actually no, let's just keep it as it is. We have an x86 machine here that we can try it on. And let's just see what we get. Perfect. It does not have a trusted signature for Edge, because I don't actually have it as a part of the repository list. So let's change it off of Edge. So let's just open up a new thing here. And we're on version 3.19, so we'll do 3.19/main. And let's copy this out. What's our actual... Oh, v3.19. Okay. Let's just copy and paste this. And let's see what we get. Why is it saying untrusted signature? Oh, not sudo, do as. And it may be because we can't read the keys. I'm curious if that's the case. So let's see. Because we do have all of these certificates, right? So if we ls/etc/apk/keys, all of the needed development signatures, everything else like that is all here. But let's see what the permissions are, because maybe we don't have direct read access. It says we do. So your guess is as good as mine. So let's see. I'm curious if we just get rid of this line, what it'll do. Oh, wait. So it does require us to put the repository, but why is it saying that it doesn't have? So just looking back at this, a repository to use for the image create. We can add extra repositories, but so first thing I'm just going to do, well, we'll delete this because we know that doesn't work. So aports, scripts, make image, where are we? Right? So we're in the right folder, aports exists here. So tag is going to be main. Out directory is going to be ISO, arch, x86-64. Right, main. And if we actually just double click this, we can see it exists. Like it is here and it's accessible. So our link is valid. And then our profile is going to be our profile name. So tag. Maybe we can get rid of that. I don't think that's messing it up though. But we're literally giving it a list of what our current one of our current repositories. So I don't think this has bearing. I am going to just try getting rid of it really quick and just see what it does. No, it has no bearing. And I don't think that has any bearing either. So we may need to just search this and just troubleshoot and see where we can actually get with it. And I see some people in chat. Hello, Jacques. I cannot pronounce your last name. And Busy. Hello to you both, and thank you for watching. So let's see what we can do to actually find out how to make this repo work. So let's do a quick search and just see what we can do. And actually, let's put in, what are we specifically running? Make image. So this is our error. Oh, it wants us to be the same architecture. So here it is. Make image should be running on the host of the same architecture as the target. So I guess we're not going to be building for x86. So let's modify our command to be able to do that appropriately. So we're on an AArch64 system, so we're going to put AArch64. Whoop. And we're going to do Edge. So let's just try it, see how it works. Okay, so that obviously makes things a lot easier. So they probably do use different certificates for actually doing the x86 version versus doing the standard ARM version. So that's why the certificates didn't come back, is because when it actually tried to validate it against the preloaded certificates, they weren't there. And Fizzy says, always want to make a departure board with Linux kernel, but don't know how to make it work. Yeah, it's certainly something where there's a lot of trial and error, I think, with anything Linux where you're trying to do something custom, or even in general. You know, it's going to be a lot of trial and error, but trying to characterize what's going wrong and then figuring out how to articulate how to search for what those issues are, it makes it go a lot easier. Because just like what we saw, where we didn't know what that error was, So coming up with what those actual search terminology would be to be able to find that, and we hit it first shot. So I think that's really, you know, for the for the departure board, I actually haven't played with that at all. I've mainly played with that Raspberry Pi, a number of other SBCs, the Libre Pi, things like that, or the, you know, some of those. But it is something where pretty much they all run on ARM chips. And I think that that's the commonality and the common thread between them. The only difference between them is some flags that they'll have set between them. But pretty much you can develop for any of these. And IT says hi. Hi to you as well. Thanks for joining. So it's still in the process of creating the file system right now. We see the percentage chugging away. And then we'll actually copy this into a file that we can boot from, or copy this onto a drive that we can boot from. And I think that that's going to be very exciting, so we made our own image. And it should also show up with the actual name when it boots, the name that we defined in our particular profile. So I think that's that also is really cool as well. So you can even put your name there. You could put the name of your project. And this is the reason why I wanted to use the Pi 5. And actually, while this is going, we could see if we could get the Pi 5 going for random reasons. And where do I have that? Because I do have another KVM connection here. See if it's actually gonna work. I do need the adapter though. And then we could actually test using that. Let's see. Oh, that would have been a good thing to build in. Ow. That was probably me. Okay, so where did I put the pies? So, right, we have the first one here. This is the first one that died. So it's the 8 GB Pi 5. I know I'm holding it up to the camera, but it's backwards, so sorry. And let's see. We actually probably don't even need a drive in this. And let's see what it actually does. Because, I mean, obviously the cable isn't bad because we're using it, but let's see, because this is going to take a minute to run. It's only at like 45%, 46%, so it's chugging along, but let's see what we got. So I'll switch over to that really quick. Let's plug this in and just see if we can get the default screen. So it has no drive in it right now. Will it do things? So we'll use this as our test bed, because obviously it's doing things. We just got to make it do things when we want them to do things. So we'll go back over to this. Oh, wait, no, we're on the computer doing this. but this would have, having the Pi 5 do it would have made it go a lot faster. Let's see, so IT says, want to create a minimal ISO with specific few apps and low size compressed. Yeah, and Alpine Linux is actually great for that, because it literally is bare bones as you want it to be. That's why it's often used for Docker and things like that. And I like it personally because it runs from RAM. So there's really not a lot of contingency in terms of hard drive, and it runs a lot faster because it is just all stored in RAM. You know, there are other options in terms of adding overlay file systems and things of that nature to other OSs, but I do like Alpine Linux just because it does that out of the box. And then Fizzy says, I'm just getting started with embedded. Do I need to learn C, or can I program with TinyGo, which I know? And you can pretty much program with whatever you want. There's different levels in terms of embedded. I mean, the key thing is that you define what the scope and parameters for your project are. So if you want it to be programmed in Go, then there's absolutely nothing wrong with that. It doesn't have to necessarily be compiled. It can be interpreted languages, things like that, and Go is absolutely perfect for that. I use Python a lot. I use PHP a lot, even for command line stuff. And, you know, C I use for microcontrollers, but I've even started to migrate over to MicroPython for things like those as well. And generally speaking, the best practices these days is actually to use the higher order programming languages instead of using C directly, just because the memory management and everything else like that is a lot safer in terms of how the code is implemented. So you don't actually accidentally get problems with it as it's running. There we go. We said it. We got it out. So we see it finished up the baseline creation of the actual file system itself. It's currently signing it, so that way we have some validation of authenticity of the ISO itself. So let's see where we get to. And it finished. It didn't do FFmpeg, that's fine. We just kind of threw it in there. And it says it successfully made the package, or made the ISO. So let's do ls ISO, and there's nothing there. It may have just errored out entirely. Oh, and syslinux is not a package. We got errors. So let's go ahead and try and fix those. We were doing so good. Let's see. So first one is the what do we call it? Oh, make image overlay. So we did. We don't want ls. We want vi. GenAPK OVO make image overlay. So this is where we define some of the stuff. So we probably should just stuck with the default. So we'll add the lsblk in the other section, just as the example. But we'll do lightpd here, just because then we can add it as default. And then we're going to do the NAS, so make image NAS, which is what we actually edited earlier. Right, we need to get rid of syslinux out of here, because that is not a real thing. And we're going to get rid of ffmpeg, but we're going to do lsblk. And that will actually make sure that it's hopefully good to go. Let's see. All right. Now we have to run it again. And oh no, I ran the wrong thing. And it's going to probably take another 1,000,000 years. Oh, that's going faster. Oh wait, no, that's step 1. That's not making the image. Busy, I would definitely appreciate it if you subscribed. So I do make videos, you know, I would say periodically. I'm trying to do it every week, but I'm trying to also change up the format a little bit to improve it. So I'm very happy to hear that you like it. So let's see. So I am kind of tempted to move it over to the Raspberry Pi 5. Well, let's just generate the ISO. Let's see what we got. Oh no. I wish there was a way to speed this up, right? Because we have the percentage counting away. And this is definitely something that you can do inside of a Docker container, as long as it's the same architecture. And yeah, I don't have one here. But pretty much, the way I see this as being like a really useful tool, in some way I want to use it, is I did order what is it, an NVMe adapter card, a hat for the Raspberry Pi that I wanted to try out. So instead of using an SD card, you would use just an NVMe drive and boot directly off of that. But I still want to use Alpine Linux to be able to do it, you know. So I don't want to have a USB thumb drive, I don't want to have the NVMe, and especially with a lot of them, the ribbon cable that actually attaches for the PCI Express bus of the Raspberry Pi 5 will block the SD card. I can actually show you that. Let's see. So here, I'll switch over here. We can still keep this up. All right. So pulling this out, we have the PCIe where the display used to be. And the problem is the SD card is right underneath it. So when you have, for example, a bottom hat, or a hob, I don't know, hat on bottom, but when you have a tray that's pretty much holding the Raspberry Pi on top of it, the cable is going to curve up and then go down, which blocks your access to the SD card anyway. So, you know, you do get significant write performance, everything else like that. It especially works for general storage. If you want to make servers, like a small web server, it would actually be perfect for that, because the Raspberry Pi 5 has enough horsepower to be able to do that. But it's something where, you know, it's still going to be using very, very little power compared to what it otherwise would. Especially for video servers, static servers for your home, things like that. The Raspberry Pi is still perfect for that. And theoretically, you know, you can PoE power these. I'm still trying to find a hat that I like that does it and doesn't start obstructing the cooling. I know they do make them, but it is something where it's not interoperable with the existing hats for PoE power on the Pi. So, you know, I don't have any for the Pi that I've gotten, and when I did get these, they obviously didn't exist yet. So I do think it's something where if you can actually PoE power the entire solution, have an NVMe storage for quick access, have full gigabit going into and out of it to be able to serve it, I mean, you pretty much got the ideal server there. Because then everything will be just very compact, but able to pretty much do whatever kind of streaming media you would want. So But yeah, I wanted to try and get some more toys or accessories, I'm gonna say. Not because I need those for the Pi 5, but just to see how exactly they compare to like full computer-based accessories. So we're still chugging away. We're only at 54%. So letting that chug away as it builds the image. So let's see. Yeah, something I am getting is, so the NVMe, but then also a case, because it does add size to the top and everything else like that. So I think that could be a lot of fun. And then especially another application that would be good for these is, since it's got the onboard CSI camera port, if you put NVMe, you could use that for storage, do some, have it act like a DVR for a security camera, and build your own. You know, not have to buy one, you can build your own. And I actually have this lens, which is the one I was using for this shot right here, but it was too close, so I got one that was wider, so that way I could digitally zoom in and out. But I thought that was potentially a good option for maybe building a bird camera. So if I have a bird feeder, I could literally just have a camera, have a little storage device, and make it so it stores from the camera, you know, onto the Raspberry Pi NVMe, and then the NVMe would serve out the video files that it stored, so I could go back and look at what the birds were doing when they were actually trying to eat everything. And let's see, IT said, through a simple GPIO project that includes a built-in timer, let's create a project where an LED is controlled by a Raspberry Pi, and it will turn on for a specified amount of time when a button is pressed in Alpine. That's actually a really good project. I had something similar to that, like that was for the game show, where you would have the button interactions going to a Raspberry Pi, running Alpine Linux for the GPI, but we would obviously need to just modify it to be able to do the push button to make it act as the time delay. So yeah, we could do that really quick. Oh yeah. Yeah, no, that's definitely true. Because we haven't added a script to it yet. We've just added packages, which is still not the whole shebang there. That's a good idea. So we could do that. So that's a good suggestion. So while this is finishing signing this, let me see what I got. So I got some buttons and things like that. Got some LEDs. Oh wait, I think I still have my game show little controller here. So I have this, which is pretty much just some lights and buttons, and they just have a bunch of the DuPont connectors on there, so we could just plug them in. So we could do that. All right, so now that it's finished, let's actually make sure it actually generated something before we continue on from here. So let's do ls, or let's actually click into there so we're typing something. And we'll do ls ISO, and there we go. So we have Alpine NAS Edge Arch AH64 ISO. So let's see. So we want to actually download this from the Pi, and then we want to generate the ISO from it. Actually, we could just generate this on the Pi. So we would be using DD to actually burn the image. Let's look that up really quick. So let's see. It's going through a lot of steps here. There we go. That's what I wanted, was the command. Okay. So, since we already have it local, we don't have to download it, anything else like that. So we're just going to use DD, and DD is just going to actually burn it onto the USB. Or, I say USB because I use the USB as an adapter. But I have this micro SD card to actually write onto, and then we can try booting off of it to make sure that this whole thing works. So I'm just going to plug it straight into the Pi. I'm going to try and plug it straight into the Pi. There we go. Okay. So now let's go over here. We're going to do the same ls command because now it should show up as another drive. So /dev, that did not help anybody. And it does look like it's showing up as USB disk. I am just going to check SDA. No, it's SDB. Okay, and the way I know is that it didn't exist before. If I was to unplug it, SDB would go away. So SDB is the one that we want. So when we actually do our command here, so I'll copy this out. I'm going to go over here, just do new line, because we obviously want to put this, but it's IF equals and OF equals are the key things. And then a few other things. So let's just try typing it in. So let's do DD IF, which is our in file, and we're going to do ISO, Alpine ISO, and then OF should be /dev/SDB1. Actually, in this case, it says just do the whole drive. So we'll just do SDB, which is the name of the drive, and it will ignore the partition table. And let's just copy and paste the rest of this over onto it and see what we got. Let's try it. We may need to do as. I don't know if we needed the BS equals 1M, so we're just going to leave it out because technically that's talking about an Ubuntu installer, which may not be exactly the same as the Alpine Linux installer. So cool, let's see. Fizzy says, my colleagues and I at the university are building our own RTK base station because manufacturers of these devices are robbing surveyors in broad daylight. Yeah, I believe it. And yeah, that's often the case. So when you hold all the chips, you tend to be able to set your own price. So yeah, it's huge to be able to actually make sure that you're empowered to be able to program and do these types of things for yourself. It pays dividends, definitely. And so the reason I did SDB instead of SDD is because we looked up the individual name up here, and it was SDB. If we had 4 drives, it would go up to SDD. So I'm not sure why they did that, but that's just the path of the actual device itself. So like here they did SDA. So it just depends on how they show up in this particular case. And it is doing things, but because it didn't recognize the progress, it didn't actually do it. But I do think I see a light blinking. Yes. Okay. I see a light blinking, so it is doing things. And I realize we also did not check how big this file was, so we don't know how actually long it's going to take in order to burn it to it. So let's see what we got. This may also be USB 2 that it's connected, because I think I was using all the USB 3 ports for other things, which probably didn't help anything, but... So, while that's running, so we'll just come up with a simple push button and make, well, you can't see that, a push button and make a light up. And we'll have that start by default as one of the baseline scripts. So we'll just need to create a simple script that will go through and do it. So we will need to just check the dependencies and make sure that that's part of it, but it should be pretty straightforward to be able to do. So while that's running, oh, it finished. It finished. Okay. So it copied, it was blazing fast speeds. It was about 1 gigabyte worth of space. And let's just confirm that. So we'll do ls-la ISO, spelling it right. Let's add an H. So perfect. So they do match. So we can actually eject that drive. We don't have it mounted. So we should be able to unplug it, put the SD card inside of our inside of the other Raspberry Pi, and be able to boot from it. So let's try that. Oof. Okay. So we'll take it, put it in. Gonna switch over to it with the KVM so it boots up with it intact. All right. So it is doing things. Will it do things we want? Maybe. Maybe. No, no, it won't. So, option B. So let's go back over here. So I got another plan. So let's actually copy the file. So I'm going to use FileZilla. Okay, and we'll go over to our drive. So that's going to be media, there it is. And we'll do USB, ISOs, and we'll just copy it back over here. And let me just... Alright, and then I'll just put this back in here. I'm going to plug it into the computer, and we'll try just copying out the files like we would creating a normal boot drive. But all of the other files should be pretty much signed and consistent. And we may need to clean this as well. But it should load right now, so we can get it prepped while it finishes downloading. There we go. That made it very, very happy. Okay, so we're going to clean this first because we see it's showing up as two different partitions. I think one of them is actually a swap file, which we don't necessarily want. So let's go more options, manage, storage. And just so you know, on Windows 11, you can mount ISOs directly now. But we see all of this here. So we have the first part, which is what we actually created, and then the second part is just unused. But there's also this little partition up here, and it's likely the boot record. And I think that that's what's messing it up, or the swap file space. I actually don't know how large it is. So let's go ahead and clean this. So we'll do CMD, we'll do disk part. Right, we're gonna do list disk. Select disk 1. And then we're gonna do clean. Right, fully unallocated. Now we're gonna format it FAT30, or not FAT32, but VFAT. Oh, we are going to format it FAT32. So it should say it's formatted, not just raw. It also doesn't say it's formatting, so let's just try formatting it. There we go. Okay, we got there. So let's go and take a look at our file, which is now finished downloading. We should be able to open it up. Right, so we have it right here. And we see it generated our APK OVL file by default right here. So we're just going to copy this and try putting it over onto our drive. Which may take a minute because, again, it's a gigabyte worth of stuff. When we do rebuild this, we're going to delete half of that stuff that is specified, because realistically, we don't need any of the ZFS stuff, and that stuff is actually pretty big. So I think that's the majority of our time is being spent trying to handle that file movement, opposed to it doing anything useful for us. But let's just try and get it to boot. I mean, that's half the battle right here, because if we can't do that, then going forward from there, it's not going to help anybody. But just for our purposes here, so taking a look at that, we need to take a look and see what knobs we can turn. Because, like, for example, we do have the overlay, which we don't have to include the overlay. But it actually could be a nice idea if you wanted it to, for example, automatically run a script to do a certain action and then set up Alpine by default, for example. You know, that might be something that's really useful in terms of actually getting there, or creating a fully headless installer. So let's see. We're just about there. Okay, so now we should be able to eject this. It's FAT32, so you have to eject it properly, otherwise it's going to mess up the file system. All right, so I'm just plugging this in off camera. Let's switch over to it, see what we get, and with any luck, it'll boot and the world will be a happy place. I have a green light, the fan is whirring away, and it's still not booting. So this does mean that there's some kind of other issue here, and we need to see exactly what it is. So let's actually just go back and let's try a default Raspberry Pi image and start there, because I think there's something wrong with what we were trying to make with that particular NAS that obviously made it so it wasn't going to work. So looking back over here, right? So let's clear the screen. Didn't work, so let's make this work. So ls, A ports, just A ports, scripts. Okay, and we have an existing one, which is mkimage ARM. So let's just take a look at that really quick. So this one has the bootloader common, which may be what it was missing from the other one, because we definitely didn't have that included. And also the user CFG, everything else like that. So if we did want to add, for example, some additional things and some options like turning on audio, for example, we could do that. So let's actually just do a duplication of this one and build it. And we can even add our push button into it, just so that way we're based on, you know, what IT said earlier, just so we could try it out. So, and we can actually edit this as well inside of a text editor. So let's see. So if we go over here, we're going to delete this because obviously this didn't do anything. So we'll go into A ports, scripts, and we're going to copy this and remake it. Or just drag it over and copy it that way. So let's come up with a new name for this. Yeah, so we'll call it ARM test sh, etc. Edit it. I want to use Notepad++. Just because I'm like that. All right. So here we have Notepad++. It highlights everything, which I think is a wonderful thing. We could use V Code or VS Code or any of those things like that. So bootloader common, excellent. APK fetch, quiet, standard out, etc. So gen command line. So these are some of the command line options right here. So SDMod, USB storage, quiet, and then the actual kernel command line. So we could modify this if we wanted to be able to include additional options like VGA mode is a good example. So if you wanted it to show VGA mode so you could read the text on a big monitor instead of it going down to microscopic 4K, you could actually do that right here as well, which might be something nice. Then we have the AArch64 and Series 1, and it's going to pretty much put into this file. Do not modify this file, etc. And that's the config.txt file. Going down from there, yep, command line.txt, config.txt. Build section, da-da-da-da-da. Shows you the breakdown, ARH64 for anything 3 and up. Image extension is tar.gz. All looks good. So let's find where to actually put our customization. So like we do have the profile here for booting and everything else like that. And this one actually does the dhcp.sh. So theoretically it would do the same exact thing. So we would change that. So let's go ahead and take a look at that file. And we're gonna make a different version of it. So this right here is what it's currently doing. So we have hostname, cleanup, makefile, rc add, so it's doing run levels. Here it is setting the host name, setting the network interface, so it's automatically doing DHCP for ETH0, and obviously initializing. I just noticed the blue line that was there, and it's obviously making the loopback connection active. So going on from there, it's initializing all of these services, everything else like that, making the APK OVL file. So I think that'll be perfect. So let's make it actually do that. So what do I have that we can take a look at and put in there? Where is my game show controller? So we'll just open this up and let's take a look at what we got. Do. Oh no, the game show controller was for, wait a second. No, it was a Raspberry Pi. Well, we'll see. All right, let's go ahead and do it from scratch. So here's the thing. So we're going to be taking a couple of pins. So we'll do Alpine Linux GPIO. Raspberry Pi. Oh, and strangely I have some videos on these things. So let's take a look. With an ad, this is not sponsored. Let's see.
Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be talking about Raspberry Pi GPIO.
Alright, so going through here, I made some chapters, which is very nice. And we cover a few examples on exactly what we could do with this. Oh my goodness. So let's see. So here I'm using Python 3 RPy GPIO as one of the library options. libgpiod is another option. But we could do Py3 RPy GPIO. But this is a good video to check out if you want to actually do, if you want to check that out. So let's do that. So we could just write a small script and include that as part of this. So over here, we would need to add that RC function and include that as part of the tar. And I do believe that this is run locally, so we could just actually put another file in there and be able to include it. Because realistically, there's no reason why it wouldn't know. I think that'll be good. Okay, so let's create a new file. So user bin Python, and we'll do import py, or not py3, RPy GPIO. We will need to include the package py3 RPy GPIO. So back over here on our APK OVL, we will probably need to include that or include it elsewhere. Because all of these are just the baseline boot, but it's not actually doing anything involving the particular OS. So let's go back out, and again, this is, for better or worse, this is the first time that I'm doing this, so let's see. So etc apk world eof. Actually, which file did they say that it was in? That was in the overlay. So let's take a look in the overlay. Although we could just make it on here. I actually don't think that they're adding any additional files, which is part of the reason why we don't see it. So we may need to add that entirely. So going back over here, it apparently doesn't care. So make dir is temp. So let's try this. Oh no, they do have it. Did you see that down here? So we want to add py3 -rpi gpio. Now, technically, that's also going to install or should, Python 3. So let's just add that as well. And that should be enough. And actually, this would go into a good kind of thing with creating our own package to actually install as part of this. So let's go back over here. We can technically do a very simple service. And these are just OpenRC services, but there's a very simple one here. And I do think that that one's perfect. So we're going to go back over here. We are just going to kind of regurgitate it into a thing potentially. So we're pretty much going to do it using the EOF method just like they're doing it. So we're going to be using makefile. Yeah, root:root. 0644 $temp for our temporary directory, /etc/init.d, and then we're going to call it, what do we want to call it? Push button? Timed relay. Okay, and then we'll do double it's hiding it. Okay. So we're just going to paste this in. It's going to be called timed relay. It's going to reference a script in user bin, and we're going to call it timed relay as well. We're not going to do any command line arguments. Command user, we're just going to run as root because we're not going to have any second users in this particular case. This PID is fine, background is fine. It's going to use network, but doesn't really matter. And all of that is fine. So we will use that. So I'm going to do the make dir-p as well, just because it seems like a good practice. And we'll do /etc/initd, just to make sure that exists. Then we're going to do the same thing. So in this particular case, so Fizzy says, can I make an .sh script a daemon? And in this particular case, we are actually doing that. So we're going to be making this script that we're going to write in a second, which is user bin timed relay. That's going to become a pretty much it's going to be started as a system service using init. So that's what this is right here. And we need to actually define it down here as well. So we're going to do rc add, and we'll do timed relay default. And that should get us into where it starts automatically on boot, and we'll start running this script. But obviously we have to make this script still. So we could just be lazy and just kind of do the same thing. So I'm just actually going to copy and paste this. We're going to replace it, but we're going to have it create that executable script. So we'll do user bin timed relay. Nala wants to say hello to everybody. There she is. Come hang out on my lap. So, absolutely. Let's see. So we want to replace all of this. Just so you see, the cat's gonna start sitting down on my hands as I'm trying to type. So it's gonna turn into like an acrobatics thing. I'm gonna leave that camera up just so you can enjoy. All right, so over here, we need to, obviously we're gonna run it in Python. So we're gonna do / user bin Python. Boop, 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 boop. So user bin Python. And it should also be fine for, Python 3, Python 2, it shouldn't care. We're going to get rid of all of this because we're going to replace this with a different programming language. And now we're going to pretty much do the script that we have in the other example that I have posted here in the comments. So here, let's copy all of this. And we can modify this to actually make it a loop. So we have our import statement to import our GPIO. We're going to set the mode of our GPIO pin. So in this particular case, we're only going to do 2 pins. We're going to do 1 input, 1 output. Then we're going to control the LED. So when we're pushing the pin, it's going to go high and it's going to go low. And then it's going to be pretty much that's it. So I have, I believe, some more full code. Maybe not. Those are the fundamental commands. So we need to add a little bit of glue here. Right, so we have our import statements. We're just going to set up our modes right off the bat. Our control LED. And we're going to do if, and we can copy this. If GPIO.input button pin, and in this case, button pin is going to be 14. We're just going to pretty much go back and forth and sleep 1 second. So we'll make it high. Sleep 1 second, and then we'll sleep 1 second again. And actually, we don't have to do that. We could just do a general sleep. All right, and now because we have an if statement, we have to indent this. We need to make sure we've imported time. We have imported time. That's right. You okay? Good kitty. And now we can go through and read it. So we're going to get rid of these lines right here because we've done that. And technically, we're not going to clean up because it's a boot process. So this is pretty much all it's going to do, but now we need to make it so this is inside of a while loop. So we will need to indent all of this. And that should be it. So as soon as it starts up, it's going to start waiting. The LED light is going to be connected to pin 17. The button is going to be connected to pin 14. And when we push and hold the button, it's going to start making the light blink. And I know originally IT said to do the timer where it's a timed off. I mean, technically this is doing the same thing. It will continue to blink for 1 second before it loops back around and does it. So you do need to hold it for at least a second, and then it will stay on for another second. So we could just change this number to however long we wanted it to stay on and have it be able to do that arbitrary timing value. So, you know, pretty much it's the same thing. And then this allows you to do that time delay. It won't make it so, obviously, if you repress the button, it's going to turn it off before it turns it back on. And you do have to hold the button for a second. So, not optimal, but I think it is simple enough and should prove the purpose for what we're trying to do here. So, let's see. File has changed. You know what? Yes, let's upload it. And let's see. Everything else is pretty much stock. And then 644, I believe, is executable. No. Let's do 755. And that should get us the permissions that we need. So we have our init script up here. We have our actual running script in user bin down here. It's calling Python, which is including the library that we installed as part of this test right here. On the Raspberry Pi Pico, and this is to Fizzy's question about without a lookup table, can I check GPIO calls instances in /dev? It won't work on the Raspberry Pi Pico just because it doesn't actually have a /dev folder. So in MicroPython, it does have a slightly different way to look at it. So you would just reference it by the actual pin number, and the MicroPython is pre-compiled with the pin definitions already included. So it shouldn't actually require any additional libraries if you have the Pi Pico unique build of MicroPython. So, but let's go ahead and get this going right here really quick and see if we can get this running. So, yes, upload it. It says it did things. Let's confirm that it did things so we're not doing things. What did we edit? What did we call it? ARM test. We still need to copy this back. Okay. Let's make sure. Well, so we have the gen apk-obl and DHCP is what we modified. Let's just make sure that it is actually showing our changes. Yes, right? So there's our executable right there. All right, so now that it's done that, and my cat is meowing, she's ready to go. Let's see. So we're gonna go back over here. this right here. Perfect. So let's make sure that we're doing that right. I'm sorry I'm doing so much checking. It's just, it seems to take a long time to actually run it. So the profile name needs to change because we changed our profile. Where did we set that? So here we put profile name is NAS. And here is where it did profile name, all of that stuff. So in our thing down here, profile is what has to be changed. So we're gonna do arm. Me? Stop. You ever meow back at your cats? So it's okay. Come here. Come here. Whoop, 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 whoop. Come on. All right. You can hang out here with me. So let's go ahead and take a look at just copying this in. We're going to change profile name to what we actually called it, which was ARM test. And just copy that in, run it, and make it work. Profile ARM test not found. What do we need it to be? Which file did it say? So specifically it said in our mkimage.sh ARM test is not found. So that's a file we didn't edit yet. Let's actually go over here, take a look at it. So this right here, so profiles. So you know what? I'm just gonna replace that file. We're not gonna do -test, we're just gonna do ARM. So let's just delete it. This is a test. We could always re-download the Git if we needed to. And we just go from there because this is the way to go. All right, and then over here, in our command, we're not gonna do -test, we're just gonna do ARM. Copy that out, go over here, paste it in. Profile ARM not found, so let's just copy it out. So whatever we set our profile name to before, which also may not work. Let's see. So it is doing it, but it's doing it back on the NAS system again. And that's the one that we don't want, because that's not the one that we just built. So let's actually make sure that we're loading the right thing. So what is actually causing it to call this particular thing? Because we want ARM. I mean, that's literally the one we want. So let's try this. Let's go back up here. Let's make sure where it's actually setting this. Because that does exist. $175 profile ARM not found. Right, so build profile 175. Profile. So where does it define profile? Let's just look for it. And I'm not actually seeing where it would do that particular thing. Because it said profile NAS for the other one, but we don't want profile NAS. We want our particular profile. So this is really the challenging thing here, because where are we going to get this? All right, so let's do this. So it may be doing the default by virtue of us choosing the architecture. But then if we have one that's here that's ARM, base, mini root, etc., I don't see why it wouldn't work. So there must be something defined in profile. So first section and section. Let's just see exactly what this has in here to be able to determine what it is. So we have one, oh, profile NAS. So what is this called? Profile RPi. All right, so we got to figure it out. So this needs to be RPI. Okay, so we got our RPi config, RPi blobs, AArch64, it's downloading, it's doing things. Let's see where we get to. I have a feeling the next part's going to take a hot second. Oh, not bad. Significantly faster because it doesn't have all of the ZFS stuff to actually download and install. So I think that's going to work to its favor to be able to kind of make this move along. Let's see. While this is happening, we know pins 17 and 14 are relevant. Right, so here, so we'll need to hook up a ground. So facing it the same way. So pin 3 is ground. Then our light is going to be pin 17. I'm going to confirm that really quick. Yep, and we did say 17. Right, so we had 17. And that is GPIO 17 for the record is pin 11. So that's 1, 2, 3, 4, 5, 6 from the top. So 1, 2, 3, 4, 5, 6. And then we have our switch, which is GPIO 14. Right, and GPIO 14 is the 4th pin down over here next to the ground. So now our GPIO should be wired, so when we actually plug it in, we should be able to boot it immediately. So let's take a look at this, and it did finish the ISO. So let's click in and let's ls this directory. Excellent, and we have the Alpine RPi edge tar.gz, which is what we want. So let's open this up, let's try and copy it over. Let's try and get it all going here. And it's 65 meg, which is a lot better than what we had before. So now we can plug this in. And where did I put that other Pi? Oh, it fell. Here we go. So we get this. We're gonna just do it in the PC. We'll open this up. So we're going to delete all of this really quick just so we can replace it with our files that we just created. And we're going to extract it. We're going to go to new volume. And it should only take a minute. while this is going, I'm going to get the rest of these cables connected. Okay, so everything should be set to go here. We see if it worked, because I don't know that the DHCP file is actually in there. We'll find out. Let's see what we got. So let's eject this. Okay. Now we can pop it in the Pi. Just do some quick connections here. Okay, we'll switch over to it really quick. See what we get. Will it boot? Come on. Will it boot? Let's get output first. So I'm gonna boot it up without anything attached to it. And let's just get video. All right, well, we got to reconnect to this one then. Because if it's not outputting any video, that's not going to help us testing this. All right. Then I'll have to figure out what's wrong with this in the future. Okay. So we're just going to transpose these over. So 4 and 5. And 6 on the other side. And actually I do this, but I realized that the Raspberry Pi 5, we had issues with that when we were trying out that video. I am curious if it's still an issue. So we may need to boot from a different Pi altogether. Okay. Actually, this is... Right, so the fan is spinning. We have a green light. There's currently nothing on there, so we should see it boot up into that. Perfect. Now we can put in the storage. So we do have life. So now I just put in storage. And let's see what it does. Excellent. So booted. We actually got it to boot. So let's see. Well, let's see right off the bat here. Do we see the name of our thing here? I do not. And I don't see the light doing anything. I don't think it ran our APK OVL file. So let's go ahead and try that really quick. All right, so switching back. We're getting closer though. It booted. It booted, which is, I'm happy about that. So let's check out what we can, what happened here. So let's go back over here. Scripts. We'll edit this since we did that. And this should reference the actual thing. We didn't add that one line saying what we wanted to do with it. So remember how we had to add that one line to the bottom of it to tell it to do things? So this overlay really is really what I'm talking about. But we had to add this line out to the bottom. So after the APKs equals, so this is the profile. Right, we're getting a little more familiar with what's the format is. So we can try this. Let's go like this. And instead of this, we want APK OVL, and we want this to be DHCP. Which should match. Again, I clicked. And that is correct. All right. So let's try just regenerating it all again. Because that should create the... So, and this time we know what to check for. Right? Because if we looked in this one, we don't have the APK OVL file that would include our script to be able to run by default. So let's try this. Let's do... Not / but ISO... Delete both of them. And let's go ahead and rerun this. Thankfully, it didn't take too long the last time around. Okay, so I got the... Well, it's still building, but... It's chugging along. So I got the thumb drive already plugged back in there. I'm just gonna quickly erase it just so that way there's no residuals. Or at least delete the contents, I should say. We don't have to do the clean erase. .30% of the way there. It's getting there. So, oh, it's moving along quick. If this was the Raspberry Pi 5 building this, I think it would be significantly faster than the Raspberry Pi 4. It is almost there. It's going to be worth it in the end, I promise you. Everybody's going to be excited. Especially me, so. There we go. It downloaded some packages. I saw a bunch of stuff there, and it errored. Let's see, is a directory. Why is that a directory? We got close, though. So what I did is I added the name of the file. It should have just been user bin, which is the preceding thing. Let me make sure I didn't do that same thing. Yeah, so I did it correctly up there. I did not do it here because I copied and pasted it. So let's see. So let's run that again. I don't know if it has to reprocess everything since it's already run it that one time. Let's see. It's definitely something where I think there needs to be some updating to that particular wiki for Raspberry Pi based imaging, but a lot of the times you wouldn't necessarily need to do it, at least in times past, because you would just copy your contents of the tar.gz file straight on there, so it's already portable. So you wouldn't have to worry about doing any kind of ISO creation. But as we move into this world where we're going to have a lot more NVMe drives and internal drives for Pi-based equipment that we didn't have before, I think that kind of changes how we have to go about installing it, since realistically it's going to be more of a formalized hard drive opposed to it just being a portable thumb drive. So, or an SD card for that matter. So I think that's definitely going to be something that we're going to have to see how it goes in the future. But, you know, somebody's got to be first. And I think that this, as far as, I mean, obviously I'm not the first person to do it, but as far as gaining the understanding of what is actually involved in terms of doing it, I think is always the hard part. Because obviously the more you get into it, the more you're kind of knee-deep in of finding out where you have to actually go to be able to edit and affect change within the script, especially one that's existing and not necessarily annotated with comments and things like that. You know, it takes a second to be able to do it. I'm sure there's people who have been in it for a while who could just walk around it, you know, without an issue. And, you know, maybe I get there someday. But I think it's you gotta start somewhere. So I'm curious to see exactly how this comes out, because I definitely want to do it for x86 machines. I want to make a mechanism to be able to do an automated installer that will image and partition the drive without having to really do anything significantly on the front end, because I want to be able to do a fully headless install, including the disk partitioning by booting off of a USB drive. That's the dream. So we do see that it did generate the ISO successfully. So let's go back here. Right, we do see it. That's not what I wanted to do, but that's okay. Hopefully this is the right thing then. Right, we do see our rpi.apkovl file here, which is a great sign. So let's extract this to our drive, we'll reboot from it, and then we should be done. Assuming we didn't make any syntax errors in our Python code. But I think a good example for this would be if you wanted to have something automatically be installed via like a Git or some web-hosted application to be able to provide that kind of dynamic overlay. I think this would be perfect for it, because then you wouldn't have to update it. As long as it was network attached, it would be able to download it. You could probably even do a net boot at that point, and it would be 100% perfect. So, you know, just some things to think about there. So let's eject this properly, just so. Go from there. Okay. So I'm going to put the SD card in here. Okay. Let's plug it in. Okay, it's starting up. We should see text. Any minute now. Let's do that same thing we did a second ago, where we booted it up and then put in the SD card. Let's see. The green light's on, it's doing things. Why is it not doing the things we want? So I'm pressing the button. That is the downside, though, about the Raspberry Pi being more powerful or more complex, is that I do feel that it's going further away from a computer that just kind of works. I do agree with the direction, but it is something where it does make it more complicated. So I'm running it without a an actual drive right now. So we should see something. And I think it's possible also the EDID detection may be too good for its own good. Right, that is on it. 3. Yep. Come on. It's so close. I know it wants to. Let me unplug this and plug this back in. Something else, I know it's not just like the capture card, because I do have a monitor right above here that I can see what this is doing. So it's definitely not booting into it for some reason. But it's not booting into the card. I mean, it's not doing anything. So let's see. Let's move it over one. Otherwise, I'm going to pull another Raspberry Pi out of a box. In fact, I'm going to do that to try and make it, coax it into working. Let's see. I do have a Raspberry Pi 3. I actually have a couple of these. And another Raspberry Pi 4. The 3B plus, the 3B may be the way to go here. So the 3B is actually what I usually use for GPIO projects. Let's try it. This one the bootloader is different, so I do have to put it in the SD card, or it won't boot up at all. Okay. I am not seeing activity. I feel like I need to get another card as a test bed. One of these is going to work. Because we do have another option as well. Let's see. Nope, we're doing this. Let's see. Alright, so I have this, which is like a Pi 4 that I made PoE powered that's DIN rail mountable. Which may or may not work. I had to put like little pin extenders in order to make this kind of work, because it's got a passive heatsink on it. Let's see. Then I have this one, which is another 3B plus. We could try this one. All of these boards are really old, and they are from previous projects that I've since decommissioned, so I don't know what the state of them is, at least as far as these older ones I'm pulling out of a bin. So take that with a grain of salt. Okay. Will it work? Are we getting any activity at all? And this one I think may be the boot drive. Alright. So it didn't boot. Let's see what's wrong with it. I can live in denial, but denial is a river. Let's see. Okay. Where is my mouse? There it is. Okay. So let's see what's actually on this SD card. Right, because all of this should be pretty much stock. So we don't have anything that's out of the ordinary here. Because we did get it to boot up a second ago, and it's AR64. But we see 3B Plus is right here. So it's got all of the required files to be able to boot. So what I'm going to do is actually just clean it first. So let's just do the same thing. So I'm going to do CMD, disk part, list disk, select disk 1, clean. Perfect. Okay, so now there's nothing there. We can exit out of that, go over here. We need to do this PC, right click, go to show more options, manage, storage, disk management. We're going to create a new simple volume. It's going to be FAT32. Okay, there it is. So now we can extract this. So we're going to open this. Okay, extract to, new volume. And then we'll try booting it and see if it goes. Cool. So let's see what we get. So let's eject this. Okay, I should add that up. All right, let's switch over to 3. And let's power it up. Bueller. It does not appear to want to boot on this. All right, before we get into the LEDs, which we will, let's just make it boot. Let's play that game. Let's just get one of these to turn on. So I'm going back to the Pi 5, because what's the difference at this point? Right? So the fan is doing things. Will we get video output? Nala is also frustrated. We literally had this going just on its own earlier. This has no SD card in it, has no storage whatsoever. It should be booting to its own internal firmware. And it is fighting us tooth and nail. So let's try swapping that around. Because option B is I'm just going to turn off the other one and plug it in. I mean, literally, this is ridiculous. Let me check. I didn't, like, unplug the cable or something back here. That's making this go weird. So what's it doing? I still don't have video. Let's try this. We are so close. All right. So now I have an official Raspberry Pi cable. Probably need to do a full reboot. There's no reported signal. For reasons I do not understand. All right, let's try this one. See, now I'm determined to just make this work. Like, that's where we're at here. It's a vendetta. Where did I put that? Oh, in front of my face. So let's try this. Oh, and actually I don't even need this. It's PoE. Right, so this one's working. Let's see if it boots. This whole time it's been working. Something, I don't know what's up with the Pis. Notice it says rpi login, right? Oh, I don't have this plugged in. Let's plug this in. Right? It's gonna be great. It's gonna be great. So let's see. So ground pin. Oh, it's not gonna work. How can I connect this? Maybe. Yeah. There's more ground pins I could use. Let's see. All right, so the light goes here. The switch goes here. Now we just need to look at the pinout, see what an alternate pin is that we could use. Okay. So far it is not working, but that's fine. But it booted and we saw some metadata associated with it. So let's do... We do see it loaded it. Actually, let's do an ls and see what we actually put there. So it lacks executable permissions, even though we said to explicitly include it. So we'll do chmod +x /etc/initd timed relay. Right? Well, and also there's issues with the init script because we just use the default. But it is here. We do see it. But we did notice also some issues with the way that it actually transposed it. Okay. So let's actually stop it and we'll run it manually. Because we probably have some other things. Okay. Interesting. So it says that that actually does not exist. So let's take a look at that really quick. That I'm curious about. Because we put it in here, user bin timed relay. That was where we went wrong. Oh, did it install Python? That's really the question. Let's see. So it didn't even create this. Anyway, we're getting too far into the weeds. I wanted to do it so it'd be nice for IT, because he brought up the idea, but I think we'll have to cut it off here. So we did make the image successfully. I mean, outside of the Raspberry Pis deciding not to boot up for whatever reason, and I'll have to do some more work offline and figure out exactly what's going on with that. But it is something where we do see that the init script did actually install correctly. So, like, specifically, the time to relay script that we created and added was successfully added to it. But it was something where we didn't have the actual bin, the executable that would have run our GPIO for controlling the LEDs. Does not look like it actually installed. Let's see if Python installed really quick. So it doesn't look like Python installed either, which obviously would have been a non-starter. Let's see. So it is missing packages, and this is from the APK file. So if we do APK fix, unable to select packages, APK update, I have to spell it right. Okay. You know why? It's because we didn't specify where it's getting it from. So let's do setup. Well, let's just do setup Alpine. Because we got to remember we didn't do anything like that. So. So right now I'm just checking networking. Right, so we just started it. It did not start on its own, by the way. So that would have been had to have been something that we added, but it did configure successfully from what it looked like. So now we can do APK update. No, because we haven't set it yet. So we need to do setup APK repos. SSL certificate error because it didn't have networking. Yeah. So we would have to reset the time, so we do /etc/initd crony, which is not set up. So we would still have to do setup Alpine. Okay. So it was close. Right, interfaces are already set up, so it's just restarting it. So it got very close, but the problem was, of course, we're using the DHCP template, which did not necessarily actually get it to automatically turn up a number of services that it actually relied upon. And I think that part of that was not necessarily, we went into this kind of blind. I think we made a lot of progress in terms of actually coming up with a fully bootable ISO image, which probably would have, well, that initial ISO image I think would have worked if it was on the correct architecture. But I think even coming up with the tar.gz file, or coming up with the APK OVL overlay file, I think was actually very good, because that did make it so we could create those offline and then be able to push that onto something else. So that is very interesting, I think. So here, this is working again. Now it can update, set up a user, no, open, and then yes. Oh, that was fun. Let's see. All right. So I don't know if you cared about that at the end. I might cut that out in post, but at the end of the day, so all right, so we made it as far as we could. I think we got a good indication of exactly where we could take it, but not necessarily the means of how. So I'm probably going to be doing some more investigation into that, and if I do find there's a good procedure or any tips that I can provide as I go on through and actually learn it, I'll go ahead and do that, and I'll share it with you guys. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And once again, if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm, and then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.